Matter is our world. Our world is matter. It's constructed of atoms that combine together to build molecules, which combine together to build materials that we can see. The fact that matter is composed of atoms was speculated a long time ago. The Greeks spoke about it. They also speculated that there are some arrangements in which atoms are arranged. Now, the beginning of science, the science of the arrangement of atoms in matter, started in 1912 with an experiment by a German scientist named von Laue. He showed that indeed, as people thought before, atoms have a certain arrangement to them. That experiment that von Laue performed in 1912, the first time he performed it, and you shine a monochromatic, which means single wavelength of X-rays onto a specimen, and the atoms in the specimen diffract that beam to form a pattern behind the specimen or back reflection in the front of the specimen. That pattern, which is composed of dots or circles, tell you everything about the structure in which the atoms are arranged. He looked at crystals, and crystals meant that atoms are arranged in a way which is periodic. Periodic is like tiles on the floor. When you know the order, you can speculate where the next tile will be. Even if you don't see it, you know that the next tile will be there and the next one there, so you know, you understand the order. And in ordered atoms, you can have several ways which you can rotate and have rotational symmetry. Rotational symmetry means the following. If you look at square tiles on the floor and imagine that you turn it 90 degrees and look again, you will not know that I turned it because it looks the same. 90 degrees again and 90 degrees. You can do it 4 times, 1, 2, 3, 4, and it comes back to the same position. This is called fourfold symmetry. Since 1912, up until 1982, when I performed my experiments, all the crystals were ordered, there was order to the atoms, and they were periodic. So the symmetries that are allowed in periodic systems are 1, 2, 3, 4, and 6, no 5, and nothing beyond 6. And so, based on that, a paradigm grew. A paradigm was created. A paradigm is something that does not come from theory, but comes from observations. And the paradigm was that crystals are ordered and periodic, no exception. And in 1982, I have found a crystal, and then several crystals, that acted like every other crystals. I discovered it in the electron microscope. They created a sharp diffraction, like every other crystal, but it had 5-fold rotational symmetry, which was forbidden by the paradigm, by the rules that the International Union of Crystallographers created. It was in the morning. I was alone in the electron microscope room looking at a new material that I just created, composed of aluminum and manganese. Right there, in the beginning of the morning, I looked at the material and it looked very strange to me. And I took a diffraction, an electron diffraction from that area that looked strange, and lo and behold, I see a diffraction pattern that has 5-fold rotational symmetry. And electron diffraction is composed of spots. So you count the spots. And I counted, there were 10 spots. And I said, no, cannot be. And I count the other way, 10 spots. This cannot be. It implies 5-fold rotational symmetry. I look again and I study a little bit, and then I said, I must share it with somebody. I mean, this is an amazing thing. The work, by the way, was done at National Bureau of Standards, NBS, in Washington, where I spent my sabbatical. So I looked in the corridor. It's a very long corridor. I looked right, I looked left. There was nobody there, nobody to share with. So I went back to the microscope and spent the whole day performing experiments. Now, what I thought was that this is a periodic material which is twinned. Twinned means that the atoms are arranged in such a way that they form a mirror image. One like this and one like this. These are rows of atoms, are arranged in such a way that they form a mirror image of each other. And in between is a twin boundary. And so I looked for twins. I couldn't find them. I make larger enlargements, larger and larger. I could not find any twins there. So I was convinced from the first minutes of my observations that we don't have twins there. So what is it if not twins? And then it took 2 years to decipher. For a couple of years I was alone. I was ridiculed. I was treated badly by my peers and my colleagues. And the head of my laboratory came to me and smiling sheepishly, and he put a book on my desk and said, "Danny, why don't you read this and see that it is impossible what you are saying?" And I said, "You know, I teach this book. I don't need to read it. I know it's impossible, but here it is. This is something new." That person expelled me from his group. He said, "You are a disgrace to our group. I cannot bear this disgrace." And he asked me to leave the group. So I left the group. And he was a good friend of mine. I mean, but he could not stand that people say that this nonsense comes from your group. This was the atmosphere. People not only did not believe in what I said, people were hostile. The community of non-believers was very large in the beginning. In fact, it included everybody. The leader of that group was Professor Linus Pauling, a two-time Nobel laureate. He was a very important figure and the idol of the American Chemical Society. And to his last day, he was standing on stages and published papers saying that Daniel Shechtman is talking nonsense. 2 years later, I came back to the Technion, and here I met Professor Ilan Blech, who was the first person to believe in my observations, and we linked force, and he proposed a model, a physical model, that explains how these crystals could form. And the two of us sent a paper for publication in a journal called Journal of Applied Physics, and the paper was rejected on grounds that it will not interest the community of physicists. And so that summer of 1984 now, I went back to NBS and met another colleague of mine, John Kahn, who is a chief scientist there. And he invited another scientist from France named Denis Gratias, and the four of us published another paper, which was published very quickly. And then hell broke loose because it did interest the community, and many scientists around the world started to work on these materials, and they called me from around the world, I have it too. And so the community of believers grew slowly. The community of non-believers shrunk. The new form of matter, which have different symmetries than known before, which is called quasi-periodic crystals, or in short, quasicrystals, is accepted into the community of crystal. So the definition of crystal was broadened to include other crystals which were not known before. It is used as strengthening particles in a steel that needs to touch the human body, such as electric shavers, also surgical equipment. It is the best maraging stainless steel available today in the world. Extremely strong steel, which can be hardened and amazing. And its strength is based on quasi-periodic materials. Hey, if you are a scientist and believe in your results, then fight for them. Then fight for the truth, all right? Listen to others, but fight for what you believe in. And fight I did. And the result was extremely good for many people, including me. Atoms in matter started in 1912 with an experiment by a German scientist named von Laue. He showed that indeed, as people thought before, atoms have a certain arrangement to them. That experiment that von Laue performed in 19 was speculated a long time ago. The Greeks spoke about it. They also speculated that there are some arrangements in which atoms are arranged. Now, the beginning of science, the science of the arrangement of combine together to build molecules, which combine together to build materials that we can see. The fact that matter is composed of atoms matter is our world. Our world is matter. It's constructed of atoms that